students from UC Irvine who are earning a minor in global sustainability as part of their degree program. And my favorite thing about this group of students is that the minor is open to students from any major. So in a group of 22, we have students who are majoring in 12 different things, ranging from the sciences to social sciences, political science, business admin, and everything in between. So it creates really unique opportunities for interdisciplinary collaboration and sharing perspectives. So each student group has chosen a topic to do a deep dive of research over the last 6 to 8 weeks related to ocean conservation or sustainability. So these are topics they've chosen that they've been learning about, and they've put together research posters and case studies on their topics to share with you all today. And so what they're going to do is just give you a little snippet of the extent of what you can learn about on their posters. And then after this, we'll invite you during the lunch to come over and chat with them here on the boardwalk and learn more and ask questions. So thank you all for being here. And if you are in the back and you cannot hear them, please, I know you can hear me, but I'm more worried that you can't hear them. So if you can't, give them a signal so they know to pipe up until we have a mic, okay? Thank you so much. I'm going to turn it over to our first group who's going to be talking about ocean warming and coral bleaching.
Hi everybody, we're talking about ocean warming and coral bleaching. My name is Emma.
I'm Jalen.
I'm Kelsey.
And I'm Jada.
So the biggest threat to our coral reefs right now is climate change, and the emissions that we put up in the air, including CO2, they get dissolved into our ocean water, which acidifies the water and rises the temperature of the water. There are algae that live on our corals that give them their beautiful colors and also provide oxygen and waste removal and other services. And when the ocean gets more acidic and rises in temperature, these algae are not able to survive on the coral anymore, leaving them pale in color, bleached, and they also are susceptible to erosion and disease. They're very weak. So it is a huge issue. And currently, the temperature since 1990 now has already risen 1.5 degrees Fahrenheit. By 2050, it could rise up to 2.7 degrees Fahrenheit, and by 2100, it can be almost 6 degrees Fahrenheit temperature rise. So it's a big issue. And our biggest coral reef here in the United States is the Florida Coral Reef, and it's already lost 90% of its coral due to bleaching. And the Great Barrier Reef, which is one you might all know about, is a huge economic asset and provides a lot of jobs. That has already lost 91% of its coral has been affected by coral bleaching. However, this isn't completely lost hope, so I'm going to pass it to Jalen to talk about some solutions that are being worked on.
So there are 3 main types of solutions for coral bleaching. There are solutions with coral restoration, ones that decrease solar and heat exposure, and ones that cool the coral environments directly. We chose to just talk about the first 2 types because they are less energy intensive as well as more realistic. So coral restoration includes efforts to grow corals in protected nurseries, microfragmentation, which is taking healthy pieces of coral and transplanting them onto larger reefs to spur growth, and lastly, protecting corals from invasive species and environmental threats like storms. These processes have restored coral cover in protected areas from 2% up to 25%, and it also helps corals grow up to 40 times faster than they would normally. For solutions that reduce solar and heat exposure, we have shading and marine cloud brightening. When we place shades over corals, it blocks solar radiation as well as lowers the sea surface temperature, which reduces the heat stress and bleaching events by up to 25%. And marine cloud brightening increases cloud cover, which in return decreases solar radiation and heat exposure. And while this solution can be very effective at eliminating bleaching, it is controversial as it is energy intensive and a geoengineering approach.
And protecting corals is important because a world without corals means a loss of ecosystem services and coastal protections. There's a cascading effect on the food web because coral is both a primary and secondary consumer. It also threatens hundreds of thousands of jobs because economies of areas that rely on fishing are threatened because the destruction of coral causes the fish population to lower. 75% of reef fish species populations decline because of the disruption.
Coral reefs contribute 9.9 trillion to our global economy, and there's a lot of ecosystem services that are provided by them, like coastal flood protection, tourism, and biodiversity. and these especially impact coastal communities, so with the degradation of coral reefs, they're especially impacted.
And there are ways that you can help, especially when on vacation, by using reef-friendly sunscreen, so no oxybenzone or oxygen oxide. Thank you. And also do not disturb the reef, because by touching corals and sponges, they are fragile, so they're easily broken. And also do not feed the fish. The reef relies on the fish to clean it, and by feeding the fish, they get too full to clean the reef, so they remain dirty. And at home, you can be a conscious consumer by choosing sustainable seafood, and as well as not buying coral as a gift, and making lifestyle changes by reducing emissions by walking and using a bicycle, or using organic fertilizers in the garden.
We have some organizations that are focused on coral reef restoration and preservation, if you wanted to take a look at them later. They have meetings that are open to the public, and they also post notes and have volunteer opportunities.
Thank you so much.
Thank you. All right, wetland. Sorry.
I might be becoming
the next group today, there's some chairs if anybody wants to come fill in. Again, if you can't hear in the back, please give us a signal. The next group is going to be talking to you about coastal wetlands and biodiversity. So we're talking about these nearshore ecosystems, the way in which our land-ocean interactions.
Hello. Ooh, okay. So wetlands and biodiversity, take it away.
Hello everybody, we are talking about wetlands and biodiversity. My name is Jared and I'm with...
My name is Carly.
My name is Ty.
And I'm Callie.
So first off, what is a wetland? A wetland is something that is either seasonally or permanently underwater. There's a lot of different types of wetlands, as you can see on there, and it really matters on how much nutrients, what type of water, and where it is determines what type of wetland it is. But wetlands in totality are involved in about 75% of all of commercially harvested fish in the US. So 75% of all the fish have some sort of their life cycle that happens within wetlands. So it's very important. And it's also $23 billion annually that is contributed by wetlands. So it's also a monetary value to keep them alive, and they're also beautiful. And I'm going to pass it on to kind of what is the problem about wetlands.
Hi, I'm talking about what the problem is. So, as Jared mentioned, there's a lot of species that rely really heavily on wetlands for at least part or potentially all of their life cycle, especially temporary wetlands, because no other biome in the world has this kind of conditions of wetlands, so they can't really live anywhere else. On top of that, 80,000 acres of wetlands are lost in the U.S. per year, not just in total, per year. Wetland area in the contiguous U.S. specifically has decreased 53% between the 1780s and the 1980s, and between 1820 and 1990, almost all of California's Central Valley wetlands were gone due to agriculture. The growing population and the increase in agriculture, as aforementioned, lead to oxygen depletion and harmful algae blooms, as well as climate change-induced heating, which predicts a 28% diversity loss of macroinvertebrate in permanent wetlands and 12% in temporary. 40% of the world's plant and animal species live in wetlands, and a third of the U.S. endangered species are housed in our wetlands. Due to the nature of the temporary wetlands especially, some species can't live anywhere else, such as in vernal pools. So we're going to lose a lot of those kinds of species the more we run out of wetlands. So what can we do about it?
So some of the things that we can do are actually making community efforts to fix the wetlands in total, and I'm about to show you an example where this actually occurred to great effects. So there's this place in Gettysburg where it was like a 21-acre patch that was heavily contaminated with invasive plants and also heavy metals in the soil, things like that. So they ended up getting a bunch of volunteers to help put native plant species in dug channels that facilitated natural wetland conditions in that area. So you can see in these pictures, this is like the before, where it was mostly just like a patch of land that had very little biodiversity in it. This is the during, where they were digging out all of that contaminated soil and replacing it with more natural stuff. And now, today, the wetland land looks like this. Way more green, way more species in it. it's got 13 acres of habitat space, which might not seem like a lot, but there's over 50,000 native shrubs in that area, as well as flowers and trees, which protect and shelter more than 185 distinct fish and wildlife species. So basically in this area, there's so many, the density of like species in that area is much higher than pretty much anything else. It's a very important landmark of that community today. For something more local, there's also the Colorado Lagoon Open Channel Project in Long Beach, which is a current land restoration project. If you guys want to get more involved, I suggest you do research on that as well.
Okay, so what can we do? Because no matter what your resources or standings are, there are ways that you can help. So we've separated it into 3 categories: physical wetlands restoration and support, legal and policy objectives, and then personal lifestyle changes. So for physical wetland restoration, come up and check out some organizations that we have listed later that have a bunch of opportunities for events locally for you to go to. For policy and legal objectives, there are tons of opportunities to vote in ways that protect native species and native land and protect endangered species. And if you come up later, we actually have some city council times for Dana Point that's completely open to the public, and they love to listen to you. So you can go to those meetings and then advocate for what you want to see happen with your wetlands in your counties for every city. So, and then third, if you can't travel or anything, there are tons of fun little ways to implement positive change in your day-to-day life, such as purchasing federal duck stamps that then have donations that go directly towards wetland restoration, and then not using like harmful fertilizers or limiting your waste. So thank you. Come check us out.
Is it safe? All right, the next group we're going to be hearing from extends the topic on wetlands to think about both the role of the land in wetland conservation, so coastal erosion, as well as the impacts of sea level rise.
Hi everybody, my name's Kendrick.
My name's Tara.
I'm Vicky. And my name's Matt.
And our presentation's about wetlands, coastal erosion, and sea level rise. As many of you may know, Southern California is home to many sandy beaches, coastal cliffs, and many natural terrains. But however, due to the proximity of the ocean, low rising ecosystems, and even the fragility of these ecosystems, these concepts are really impactful to change and actually overall the coastal erosion of our shoreline. And I'll hand it off to Tara to talk about our sea level rise.
So regarding sea level rise, that's expected to happen with a 1.4 meter expected sea level rise by 2100. And that's projected due to climate change, which will melt the Arctic and Antarctic glaciers. And when water is warmed, it expands. So that's also going to increase the amount of space it takes up, causing that sea level rise. And some of the effects of that will be a decreased habitat for all coastal organisms, and that even includes humans. So like we see in the background, there's a lot of people living really close to the ocean, and even if their houses aren't directly touched by the water is going to destabilize these rocks, and it can pose a large risk to the people living in those houses. There's also going to be a huge financial burden as a result. So this map shows that the financial expected costs of rebuilding all the buildings or just moving the buildings back due to sea level rise. And in Orange County, it's a really huge number. It's $17 billion. So that's what our state is going to have to spend if we're going to be more cognizant about sea level rise. And so here we have another map and histogram, and the map depicts the cliff retreat, and that is going to be a huge problem over here since we have these large bluffs. With sea level rise, the erosion is going to increase, and we'll be talking about that next too.
Okay, next we're going to be talking about coastal erosion. Coastal erosion is basically the shoreline retreating inland, or in really basic terms, the ocean getting closer to the land. And coastal erosion is a naturally occurring phenomenon, but due to anthropogenic causes such as urbanization, causes made by us, coastal erosion has grown to rates that are relatively unmanageable. Between 1998 and 2010, 44% of the Pacific shoreline has seen evidence of coastal erosion. And some impacts of coastal erosion are loss of biodiversity or disruption of natural ecosystems, and it can also impact us as well. It can lead to loss of infrastructure, such as like our beaches or buildings near the beach. And by 2080, runoff is expected to increase from 200 to about 400%. And there is expected to be like an increase in flooding events and storm surges. Some possible solutions to coastal erosion, there can be like green solutions, which involve like vegetation or utilizing natural like vegetation or ecosystems. Those are more like soft solutions, or we can do like harder solutions, which are called like gray solutions, which involve things like building certain types of infrastructure, such as like literal walls, in order to prevent more coastal erosion.
And then I'll talk a little bit about wetlands just in like the context of coastal erosion and sea level rise. So they're super important because they do buffer storms. So up to 60% of storm wave reduction is attributed to wetlands. So they are very important. They also, harbor a lot of endemic species that can only live in that specific spot and ecosystem. So sea level rise converts wetlands to mudflats, and that's like pretty detrimental because it reduces biodiversity. We do have a little bit of a like visual here, and we can talk a little bit more about it if you want to stop by and see. But it's about Newport Back Bay, so it's a very local wetland of ours. And some solutions are developing, are kind of just like constructing artificial wetlands and also reducing like the amount of urban development so that these ecosystems can move inland.
And on top of that, including the possible solutions that my peers have already mentioned, there's also other volunteer opportunities that are available to us locally and also nationally. But of course, there's always going to be your daily life where you can always mitigate CO2 emissions or just reducing your carbon footprint. But there's also other organizations such as the Wildlife and Wild Care Center of Orange County. There's going to be Save Oceanside Sand, and then as well as the Beach Erosion Authority for Clean Oceans and Nourishment, which I could talk about later if you come by our table. But thank you, that's it.
All right, 3 more. Who's next? All right, I have to remember the order that I told them. So our next group is going to be talking about another issue that connects the land with the sea, and something that has been in the news, especially in the last year or two, and that is red tides and algae blooms.
Hi everyone, I'm Samantha.
Hi, I'm Dorothy.
And I'm Edward.
And we're talking about red tides and harmful algal blooms. So, harmful algal blooms are caused when a species of algae, usually a dinoflagellate, it just blooms out of control. Like, it just keeps growing and growing and growing. It doesn't stop until there's not enough resources to keep it going. And red tides are a type of harmful algal bloom. They're caused by a species of dinoflagellate, and they usually appear red or brown. And there's been a massive increase in the past few years. There's been, like, in the 1950s, there were 49, in 1960s, there were 49 global red tides, and 405 global red tides by 2008, which is a massive increase. So you're probably wondering by now, what causes them? And it's actually runoff, usually from agricultural productions. Large increases of nitrogen and phosphorus, usually from like pesticides or fertilizers, run off into bodies of water, such as coastal areas, and usually there's not a lot of nitrogen or phosphorus there. So the algae's like, hey, it's free real estate. and they just bloom out of control. They use up all the oxygen in the area, and then they die, and they're broken down by bacteria, and that uses up oxygen as well. And it just keeps going until there's no oxygen to support any life. And that's called eutrophication. And now to Dorothy.
Right, to help you understand the gravity of red tide impacts, about 100 tons of fish die daily during these harmful algae algal blooms.
Hold the microphone
closer. Okay. And that's equivalent to about the size of a blue whale, so really big deal. And really devastating impacts on our aquatic and coastal ecosystems. And so you can also imagine how this affects human life, tourism and the seafood industry, how jobs and people's livelihoods are affected, people's money, we all love that. So, and most importantly, public health. And so a case study in Florida actually found 500 patients were hospitalized due to toxic poisoning, due to exposure to these red tides. So a good day at the beach turned to a day at the hospital. And there are also other human health impacts like paralytic and neurotoxic shellfish poisoning. So as these toxins bioaccumulate to higher trophic levels from the smaller trophic levels of shellfish, it affects us, yeah. But not all is lost because
there are ways that researchers are looking into understanding algal blooms a lot better and finding ways to prevent them. So first up is monitoring systems. So they track, locate, and assess algal blooms when they occur, and it's really important in preventing them. So because it helps researchers understand why they are formed, and it can help them find ways to prevent them as well. Next up, researchers are also cooperating between state and local researchers to help develop and test technology. So by doing that, they can share resources with each other and collaborate to make sure that everyone is informed and updated on algal blooms when they are happening. And then last up, there's also educational programs that these researchers are hosting to better educate the public about algal blooms. But how we can get involved as ordinary citizens is basically just practicing sustainable measures. For example, we shouldn't use synthetic fertilizers, and instead we should use organic ones to prevent the nutrient runoff into the oceans. And in addition, is basically staying socially and politically active. So be sure to contact your state and local representatives to let them know about the harms that algal blooms are creating, and also to report them to local organizations to let them know when they're happening and to prevent them. So, yes.
And you can come by afterwards and come check out our poster. We got more graphs and we got more references.
Thank you.
All right, thank you. So please hold the microphone as still and close to you as you can. And we're thinking that it's working better on this side. So maybe if the speakers come here, we're getting better sound. Does that make sense? Or you can come over here when you're the speaker.
Okay.
Thank you, Jared. Okay, next up we're going to be learning about aquatic invasive species.
All right, guys. Hello, my name is Kathleen.
I'm Lizzie.
I'm Faith.
And we are doing our project on aquatic invasive species. So you might have heard this name throughout the presentations today, but basically invasive species are organisms that are not native to any region, ecosystem, environment, and they can be plants, animals, microbes, and are most often introduced into their environments unintentionally, but can also be introduced intentionally as well. And we will be focusing on aquatic invasive species, so you'll be finding them in oceans, freshwater environments, you name it, they're probably there. So why are invasive species such a problem? So some reasons why they're a big deal is they outcompete native species for resources, number one. They also alter fundamental ecological processes, and they cause big losses, cause extreme losses to biodiversity, and they cost local and federal governments billions of dollars. Bundle statistic we have on that is aquatic invasions have cost the global economy in US dollars $345 billion. And this cost have actually increased exponentially, especially here in the US. So in 2020, it would actually cost the US $23 billion. And this uptick in cost definitely is attributed to climate change, as invasive species can thrive and adapt very well in warmer waters. So with rising global temperatures, they can adapt much better than native species, which as a result, they can no longer outcompete their invasive counterparts. So we have, if you want to come by later afterwards, we have some graphs showing this in a study in California. So yeah, just come by.
So a case study that we wanted to highlight was an invasive plant species that's known as the killer algae. The name is Culpera taxifolia, and it also has a like similar species, Culpera prolifera, that are two extremely invasive green algae species. So they're native in the tropics. However, a lot of people use them as decorative plants in aquariums, and then the issue is that people will dump them in bodies of waters or oceans, and then they quickly invade non-native waters, displace native species, and threaten marine ecosystems. So we have some pictures here. And then invasive species have like significant impacts on the ecosystem and on people. So for ecosystems, they displace fundamental ecological processes. Some of these include nutrient cycling and sedimentation, displacement of or modifying habitats, and changing food webs. And then for people, there's significant economic and health impacts. So some of these include decreasing fishery and aquaculture revenue, and there's like a high cost for management and removal. And then for health impacts, it can spread dangerous diseases and reduce water quality. And we have some graphs to highlight these if you'd like to come up and look afterwards.
Thank you. So now I'm going to be talking about essentially organizations, resources, and what you guys as individuals can do to help stop invasive species. There are various organizations that are helping to stop the spread of aquatic invasive species, ranging from local to international efforts, such as Cal IPC, the California State Lands Commission, and the Invasive Species Specialist Group. They all do various things, such as assisting policymakers, spearheading research, and also educating the general public. There are various resources that we, as just people who are not experts, can refer to in order to learn more about the issue, such as the National Invasive Species Information Center. They provide a large network of various links connecting different states around the country with very detailed information regarding the invasive species in their specific regions. And there are things such as the Cal IPC, as referred to up here, that provide things such as a cow weed mapper that can actually provide you with pictures and descriptions so that you as an individual can identify these species and help stop the spread on an individual level. Now, how you can stop the spread is doing very simple things in your day-to-day life, such as properly disposing of unwanted pets and plants into the trash bins, as well as making sure that you dry off any fishing gear or boating gear that you have before leaving the area so that you don't spread these species on accident. Finally, you can do various things to get involved, such as attending and volunteering with local organizations and donating to the cause. So if you do have time to stop by our booth, go ahead and scan the QR code, and here we have various links leading you to different organizations you could help out. Thank you. Thank you so much for your continued attention. I'm glad they're having more success with the microphone than I am. I realize there's 5 minutes in between you and your well-earned lunch, so we will get going here. Our last topic is ocean pollution, but it's a very specific issue for which I didn't know a lot about. I know when we think about ocean pollution, we often think about plastic trash, which is, what we're talking about a lot here today with Stand Up to Trash, and things like oil spills. But this is going to talk specifically about ocean fuel pollution, primarily from shipping.
Hi everyone, my name is Julia.
My name is Isabel.
I'm Alana.
And I'm Julia, and our topic is ocean fuel pollution. So ocean trade is a large part of the modern economy, and along with globalization, increasing consumerism is increasing the increasing the need for international trade. And as we can see in the graph in the middle, international trade has been increasing over the last few centuries, and about 90% of trade is now by sea. And this trade is done using these sea vessels, which are these massive ships that carry about 200,000 tons, and they use low-grade fuel called bunker fuel, which is especially polluting compared to other types of fuel.
I'll be talking about the problem and why we should care. Since cargo ships are responsible for 90% of our global trade, we experience a lot more idling and fuel leaks. And this doesn't only affect our big oceans, it affects shallow waters like Lake Tahoe, and as well as we see continued negative impacts. And because global trade is by cargo ships now, that we see a lot more fuel pollution, but because not all of our fuel leaks are reported, then we don't see the major impact that are caused by it.
So our group looked into 3 main case studies, and what I thought was interesting about these is that they all are directly related to Southern California environments, like Dana Point. So the first one we looked at was the reproductive impairment of Southern Californian fishes, like the white croaker fish. Any fishers in the crowd might recognize the little guy on the left. But we saw that there was that out of all of the female white croaker fishes, only 54% of them were able to reproduce and spawn due to loss in fertility. The second case study we looked into was the impacts of motorboats on fish and wildlife, and how the ecology of fishes was drastically impacted by by pollution in the ocean caused by boats. And the final case study we looked into was watercraft and the contamination of sediment, and how particle reactive contaminants in the water built up in more shallow environments like marinas and embayments, and how that had an effect on ecology and the water quality in the area.
Okay, so now I'm going to talk a little bit about some of the impacts. So obviously we have animals. These include otters, fish, eggs, you name it, probably impacted by ocean fuel pollution. Something interesting though is that it also impacts ocean plants, which actually absorb 90% of excess heat and 1/3 of the CO2 emissions, which combat climate change. And it also most visibly impacts the surfaces of our oceans, which can be bad for Dana Point, as most people come here because it's so beautiful.
And then just a few mitigation measures. Most of the mitigation measures for fuel pollution in the ocean primarily focuses on changing ship fuels to reduce emissions. There are regulatory frameworks that prohibit the intentional introduction of chemical agents and provide guidelines for oily wastewater discharge. And something that we found interesting is that there are efforts that are being made to have ships plug into power sources at ports.
Okay, and then I'm going to talk about like some organizations and ways to get involved. So first up is the Ocean Institute. So yay, you're one step closer. But they educate 100,000 visitors annually, and ways you can get involved are coming to things like this, volunteering and donating and partnering with them. And then we also have at a statewide level the California Coastal Commission, and at nationwide level Oceana. And ways you can get involved in these are by signing petitions, donating, or joining meetings. And then some easy lifestyle changes are just like buying from local businesses instead of like using Amazon or something to ship something to your house, just so that we lower the import demand for gas and other ocean fuels.
All right, thank you so much. We have one final round of applause for all 6 of the groups today. So they will be heading with their posters over here next to the Stand Up to Trash booth. So I welcome you as you enjoy your lunch to come and speak to them, ask questions, and get an up-close view of the research that they've been doing.
Thank you.